Hi, I'm Rich with insideHPC. We're here in Frankfurt, Germany at ISC 2018, and today we're at the PGI compiler booth, and I'm here with Michael Wolfe. Michael is the technical committee chair for OpenACC.org. Michael, thanks for having me here today. First, let's start at the beginning. What is OpenACC? What is it for?
So it's a programming language model to do highly parallel programming, specifically for highly parallel systems like GPUs. But you know, today's CPUs have a heck of a lot of cores as well, and that number is growing. So OpenACC should work well both on many-core, multi-core CPUs and on these highly parallel GPU accelerators.
So Michael, if I was going to port my code, why would I want to use OpenACC and things like directives? Why would I go that route?
That's a very interesting question, and we get a lot of people who learn the answer to that. So we have a lot of success cases, and the reason for using something like directives is I want to have one version of my code. I don't want to have to maintain two separate versions of the code. I want to have the same code that runs well on my multi-core CPU, on my GPU, or whatever other system I have. Now, I can go into much more detail than you want, but all of these systems have the same sorts of parallelism. I have multiple cores, I've got SIMD operations, multiple threads per core. Some of them have more parallelism in different dimensions. But if you express the parallelism in the right way, and you have the right tools supporting that, you should be able to have, in most cases, pretty much the same program running well on all those targets.
So with the work you're doing with OpenACC, what's next?
That's another interesting question. So we've been doing minor releases. We did a minor release last year, added some minor new features. This coming year, we're going to have another minor release, add some minor new features. And so things like having the host, treating the host like a device. So you can dynamically select, I want to do this part of the program on a multi-core CPU, that part of the program on offload engine, my GPU, or what have you. That'll be something new. That's a relatively minor addition to the specification. There are some other things we're looking at that are a little bit more aggressive that may not make this minor release, that are going to wait for something else. One of them is the whole deep copy problem, which is if you have these dynamic data structures with pointers in the data structures to other data structures that may have pointers to other data structures, and I need to move that over to the device memory. How do we do that efficiently and effectively? That's a hard problem. PGI is doing a prototype implementation. If we can use that to sort out the problems and details. Another one that is an issue today and going to be more of an issue in the future is we've got these systems where when OpenACC was designed, you had basically a device memory here and host memory here. Now we have, well, they share some memory. Maybe they share the address space, but not the physical memory. But some of the data will be in where you don't have to move it, the system will move it automatically. How do we fit that into the specification where some of the data is in shared memory and some is not? So that's something we need to think about much more deeply. And another one that's a really hard problem, which I have heard no really convincingly good solutions for, is I want to have multiple GPUs. I want to use multiple GPUs, like, I don't know, Summit, 6 GPUs on a node. How do I use all those effectively? And maybe the multi-core powers as well. So those are some open problems that we're looking at for the future.
Well, what's the call to action here? What would you say?
Well, it depends on who you are. If you're an application developer and you want to move to GPU acceleration, OpenACC is your best on-ramp to get started. Now, it doesn't necessarily mean it's going to solve all your problems. You may be wanting to use CUDA to optimize those deepest, darkest kernels. If in some cases, OpenACC, you need features that OpenACC does not provide. We had an example that came in today. Someone said they wanted to use the texture cache for the interpolation features. Is there a way to do that? Well, that's a feature in the hardware that doesn't exist in any other hardware, so it's not particularly portable. But it's an interesting feature, so OpenACC does not solve that problem. But for many cases, this is the way to get started, and then you can get your code over there and then start focusing on your other pieces of code. If you're a researcher, the call to action is, let's look at some of those hard problems like multiple devices, and how do we express that conveniently, effectively, and get really good performance. And I'll have to admit, I don't know what that answer is going to be.
Well, thanks for sharing that, Michael, and have a great week here at ISC.
Thanks very much, Rich. Good to see you again.